Hey there, and welcome. We're about to take a look at the very ground we stand on. And you know what? We're going to find out that our planet's surface is way more restless and alive than you'd ever imagine. So let's dig in.
So, I want to kick things off with a pretty wild question. We walk on it, we build our cities on it, we think of the ground as, solid, the definition of stable. But what if it wasn't? What if it wasn't solid at all?
Well, here's the crazy part. It's not. It really isn't solid in the way we think. The very continents we live on are moving right now as you're listening to this. It's happening incredibly slowly, sure, but it's constant. So how on earth is that possible?
To get our heads around this, we first have to accept this one simple, amazing fact. The ground is always moving.
Okay, so how fast are we talking here? You might be picturing something dramatic, but get this, it's just a few millimeters a year. That's about the same speed your fingernails grow. Now, that might not sound like much, but when you play that out over millions of years, that tiny movement is powerful enough to slam continents together and tear them apart, literally redrawing the map of the world.
So what kind of engine could possibly be powerful enough to move entire continents? Well, for that, we need to look deep inside the Earth. To understand this huge process, let's actually start small. Think back to science class. You know when you heat up a beaker of water? The warmer stuff at the bottom rises, it cools off when it gets to the top, and then it sinks back down again. It creates this constant circular motion. That's called a convection current. And believe it or not, that simple little beaker is a perfect miniature version of what's happening on a planetary scale. Deep inside the Earth, molten magma is churning away in that exact same circular pattern, creating these enormous, super slow-moving currents. That is the engine driving everything. You see, the Earth's crust isn't one solid shell, like an egg. It's actually broken up into these massive, rigid slabs called lithospheric plates. The best way to think of them is like giant rafts. And these rafts are just floating on top of that churning magma engine, carrying the continents and the ocean floors along for the ride. Now, even though the movement of these plates is incredibly slow, the moments when they interact, well, the consequences can be anything but slow. They can unleash some of the most sudden and powerful forces our planet has.
To really get this, it helps to think of the forces shaping our world as two different teams. First, you've got the endogenic forces. Think of them as the builders. They work from inside the Earth. Then you've got the exogenic forces, the sculptors, which are busy working on the surface. Let's start with those powerful builders.
Volcanoes are the perfect, most dramatic example of an endogenic force. They're basically a safety valve for the planet. All that immense heat and pressure from below finds a weak spot, a vent, and erupts onto the surface, often building brand new land.
But sometimes that pressure isn't released through a neat little vent. Sometimes those massive plates themselves just suddenly slip or grind past each other. The result is a massive vibration that ripples through the crust, and we call that an earthquake.
To get a real sense of the energy we're talking about, let's look at a case study. On January 26, 2001, a huge earthquake, a 6.9 on the Richter scale, hit the town of Bhuj in India. For context, anything over a 6 is considered a major, very destructive quake.
And this is what that looks like. A 6.9 isn't just a number on a chart. It's a force that can literally level a city. It's a terrifying look at the raw, destructive power of those plates shifting beneath our feet. I mean, the headlines from that time just paint a horrifying picture of the total chaos. You had hundreds of fires breaking out from cooking stoves that got knocked over. School buildings collapsed, and tragically, almost 1,000 students and teachers were lost. All the essential services, phone lines, water, power, gone in an instant. The president had to declare a state of emergency. It was an absolute catastrophe, all because of a sudden slip deep within the Earth. But that's not the whole story. While those endogenic forces are the violent builders, there's that other team constantly at work on the surface, the patient, persistent sculptors. There's a perfect quote from our source material that says it all. The landscape is being continuously worn away by two processes, weathering and erosion. So weathering is just breaking the rocks down. Erosion is what carries all those little broken pieces away. These are the tools of our sculptors.
Sea waves are an amazing example of this. They're relentless. They start by pounding away at cliffs, finding tiny little cracks, and, over centuries, widening them into huge sea caves. But they don't stop there. They keep going, carving all the way through the rock to create these beautiful sea arches. And even then, they just keep at it, until finally the arch collapses, leaving behind these lonely, dramatic rock pillars we call stacks.
And it's not just water. Glaciers act like these giant, slow-motion bulldozers, literally carving out entire valleys. And then you go to the desert, and there it's the wind that's the main artist. It sandblasts rocks into these crazy mushroom shapes and piles sand up into massive, shifting dunes.
So if we pull it all together, you can really see the work of these different artists, and notice how each one both takes away and gives back. A river might carve a powerful waterfall, but then further downstream, it deposits all that silt to build a rich floodplain. Glaciers carve out deep hollows, but then they dump all that rock and dirt to form moraines. It's this constant cycle of destruction and creation.
Okay, so let's bring these two giant forces, the builders from below and the sculptors from above, together to get the full picture of our planet in motion.
When you get right down to it, the world we see every day is the result of this epic, ongoing tug-of-war. It really is an unfinished masterpiece. It's constantly being built up by those sudden, violent forces from within, while at the very same time it's being slowly, patiently carved and worn down by the forces on the surface.
And this all leaves us with one final, kind of mind-bending thought. We live our lives on a human timescale, right? Days, years, decades. And on that scale, the ground feels solid. But the planet? The planet operates on a scale of millions of years. So if you could hit fast forward and watch the Earth for, say, 1,000,000 years, what do you think you'd actually see? Imagine the new mountains you'd see rise up, or the coastlines that would just get erased by the sea. It's a pretty powerful reminder that our world is never ever finished.